All right, so here's what we're going to do. Here's what we're going to do. We're going to finish up the practice test right now. We have a test scheduled for Tuesday, okay? So here's the deal. We'll review again tomorrow. If I don't see you on Monday, the test is on Tuesday, okay? We have office hours tomorrow. We have office hours on Monday. Right? So if you're not getting something, it's time to get that taken care of. Tomorrow, after we, or actually maybe today, but probably not. After we do this practice test, I want to take all homework questions, get all that sorted out if there are any, and then we got one more practice to do, okay? So here we go. We are on the one called review number 2. And we had, because of the quiz, we had skipped number 9 and gone to 10. So we need to go back and get number 9. 9 was not on your quiz, but 9 will be on the test. So you need to make sure you can do number 9. Okay? So, number 9 says equation of a quadratic function. What does that mean, guys? Quadratic function. What's it look like? X squared. Looks like a parabola. Right?
Yep.
Parabola. And there are a couple of different ways you can look at the equation of a parabola. One way that you can look at the equation of a parabola is the way you've been looking at it in your projectile motion problems. That's a parabola. But another way we can look at the equation of a parabola is like this. And what is nice about that form right there? You know the vertex. This means right 3, up 4. That's your vertex form, right? So if they tell me the vertex, they tell me what it is, it makes sense to write it like that. If I know the vertex, then don't I know x plus 2 squared plus 1? Wouldn't that put the vertex at -2, +1? So what's missing in this equation? Then this guy right here. And I'm going to find him by plugging in that. Now, I've graded a zillion papers. I know what's going to happen. Somebody's going to plug that in here. No, this is called the vertex form. So the numbers you actually plug in to build the equation, the numbers that are in the equation are the vertex. Now, I'm going to go ahead and plug that in, but only to find my n. PEMDAS. 4 plus 2 is
6, 36.
squared, 36n. Don't be
37.
adding the 1.
Oh, no.
It's 36n plus 1. Oops, that's 1. And it looks like n is 536. So this is your answer. The numbers that are actually in the equation are the vertex. Left 2, up 1. Left 2, up 1. Okay? You gotta remember this is the form, vertex form. All right, we already did 10. Number 11. The volume of a gas varies inversely with pressure. So I have volume and I have pressure. It's either going to be V equals Kp or V equals K over P. Those are your two formats for the variations that we discussed. There are other variations, but we've only done direct and inverse. That's all we're doing. So which is it? Is it V equals K times P? V equal K divided by P. That is your inverse. That's your inverse. Now, when we took a quiz over this, I literally guided you through step by step. I'm not going to do that on test day. The next sentence says, oh, wait, no. Oh, no, it does make it, sorry. Write an equation for this relationship. There it is. V equals K over P. Find the constant of variation. If the volume is 100, when the pressure is 10. So what would K be? That's called the constant of variation. Wait a second, Tom.
I had an appointment. I just got here.
How's it count?
All right. What's our constant of variation? That's our K. What is that? 1,000?
Yes.
And then normally, we have an additional question. That's what's left out of here. So let me just add another question. Suppose it said, find the pressure when the volume is 600. Well, what would we do? We go back to our equation. The volume is 600. K is 1,000, and I'm finding the pressure. See what I did? Can't solve when you're in the denominator. That equation's not solvable like that, so we gotta bring the P out. And so our pressure would be 5/3. I think that's 5/3. Take out the 100. 10/6. All right. If it had been direct variation, everything would be the same except you'd be using that equation. Right? All right, now I'll get calculators out. All right. Been forever since you did one of these. Help me out. Put
Table.
it in.
Stats.
So the stat and edit. Yep, so wait, let's everybody do that. Stat, edit. Now, I was actually using this in an earlier class, so I have a bunch of data in here. Remember, you can either type right over the data that's in there, you can manually clear it out, or you can highlight L1, go up and highlight the L1, hit clear and enter, and that will just empty it. If you have data in there, that will just get rid of it. So you don't need to worry about it if that's what you want to do. All right, and then don't put the 5 in, just put these 4 in. So we're putting in 2, 3, 4, and 7 for L1. And then 12, 38, 82, and 382 for L2. So X's, Y's. Okay, then you remember what to do? Good, you remembered how to get the data in. Stat edit. Now we go to stat again, but this time we pick calc. And then read the problem. It specifically tells you to choose cubic. And remember, it gives you the format of the equation. It will always tell you. So for a cubic, the format of the equation is this. That's the format of the equation. It's written right there. It's the first thing on the calculator. Then it gives you the values. So what does it say?
-3.
Well, A is 1.
Yeah.
I think we talked about this before. What do we do with that B value?
It's like 0.
It's 0. That's 0. So there's no B. C is 7, and D is negative 10. So there's the equation I came up with. You okay? Now, the question ultimately is, if X is 5, what will Y be? So what will we do? Plug in 5. And did you get 150? Very, very good, you guys. I'm happy with that. Awesome. All right, let's look at the next one. CJ's company determines that the supply function is this. This sounds like an econ problem. Okay? And the demand function, that should be a P there, not an X. Sorry about that. And we're gonna find the price where the supply will equal the demand. What should we do? Set these equal to each other, don't we? Well, I mean, we want to know where these two are equal, where do they cross? So we can go ahead, and type in that equation. Okay, so I'm going to type in y equals 5 plus 0.001 x squared and 10 minus 0.02 x cubed. Okay, and then hit graph. And what are we looking for? Where they cross, so let's find that. So second calc intersect.
Bless you. Thank you.
And I'm gonna come up with an ordered pair, 6.283, comma 5.039. Is that what you got? Now I need to decide which one do I want? Find the price. That's the X. So the answer is, I guess that's dollars, it doesn't really say, but it's like $6.28. Or 6.283 whatevers. I guess it's dollars, I don't know. Everybody okay with that? Mrs. Ford has 60 pounds of scrap paper. I'm gonna sell it to Mr. Knoll each day. She waits to accumulate 10 more pounds. The present price is $2, but every day we wait, we lose 25 cents. How many days should she wait so we can sell the paper and maximize income? Does this sound familiar? This was a quiz question. Right now, if I want to sell my paper, right now, I have 60 pounds and I'm going to sell it for $2. Right? That's how much I make right this instant. Well, I'm greedy, I want to make more money. So what am I going to do? Well, what's going to happen to the number of pounds I sell? Right now it's 60, but that is going to go up by 10. So plus 10x. And then the price right now is $2, but that is actually going to go down by 0.25. Yeah, right? And I want to know the maximum, so I want to know the vertex. So this is going to be 120 minus 15x plus 20x minus 2.5x squared. Hopefully my arithmetic is okay. How does that look to you? Does that look okay? All right, I want to know the vertex. How do I find the vertex without graphing it? Negative b over 2a, and won't two of those also be negative 5? So positive 1. And then I'll plug in 1. I can plug it in anywhere. I think I'll plug it in here. I plug in 1, that'll be 70 times $1.75. So 70 times $1.75, 122.50. Make much more money, but it's a little bit. What does the question say? How many days should she wait? 1 day? 1 day. What is the 70? That's how much, if I wait 1 day, that's how much I'll sell them for? And what's the $1.75? If I wait 1 day, that's how many I'll sell. This is how many, or the price I will sell them for. So if I wait a day, instead of selling 60, I'll sell 70. But instead of charging $2, I'll charge $1.75. All right, one more and we're done with this paper. Taylor lives in the house below. So the house is 30 by 60. What am I doing? So I'm only putting a fence around 2 sides of the house. And the total area is 10384. All right. Anybody feeling like you can build an equation? That?
60 plus x, 130 plus x equals 10.
Wow. Was that you, Elijah? Yep.
Good job.
Because isn't that a rectangle?
Sure is.
And this is the original 30 plus x more. And that is the original 60 plus x more. And how do we find the area of a rectangle? Length times width. Okay? Now, this is a calculator problem. So you really, it's kind of wide open. Could you type this in as one equation, like y1, and type this in as the other equation, y2? Would that work?
Mm-hmm.
Yeah. What else might you do? You might FOIL it out, and that would be easy. These numbers aren't bad. We just have options, kids, because we have our calculator. So x squared plus 90x, and then I'm going to bring this over so that my equation is set equal to 0. So that'll be 10384 minus 8584. So again, this is a calculator problem, so it's wide open. You could, after you've built your equation, you could type in this as y1, this is y2, and look where they cross. You could also, because you're in the habit of foiling, you could FOIL that out and get your equation set equal to 0. Then, if you want, could you use the quadratic formula on this? Yep, sure. The numbers are going to be big, but you don't care because you're using a calculator. Right? Okay. So, somehow solve it. Let's see what we come up with. Obviously, with the size of these numbers, if you are going to be graphing it, you are going to have to pay attention to your window. Because you got some big numbers in here.
Moving negative 90.
My calculator's so slow.
Negative 90.
Yeah. Oh my gosh, I don't believe it. No, I mean, that's actually a perfect square. So one of my answers is 58. And the other one will be negative, so I'm not gonna use it. Find x. X is 58. So however you chose to do that, and I ultimately gave up with this and just use my quadratic formula. Okay? Alright, that one's done. We're going to get ready to start the next one here. But before we do that, are there any, and I'm talking about in chapter 2 period. So 2-1, 2-2, 2-3, 2-4, 2-5.
I have a question for like the quiz that we just took. So the first
I'm
question
going
is
to
like,
hand those back
what?
tomorrow. Can I wait till tomorrow? I'll hand them back tomorrow.
Oh.
That
Oh,
way
I'll be
everybody.
here tomorrow.
Not my problem, dude.
Well, like, it's like multiple people involved because of art history field trip.
Yeah, field trip.
What is your
Did you
question?
get that mission?
The first one was like the remainder one. I forgot that you could just like add them up. I
No,
just
I
did
gotta
one
finish.
division. We're just looking at the same answer.
If you do it correctly, yes, you will get the same answer. To find a remainder, you can always divide, always. But depending on the problem, sometimes it's easier just to plug the number in. But you can always divide.
Okay.
All right, anything else from the paper homework that I've handed back?
I was finding the zero.
Yep.
How did you get to 58?
Type that in the calculator. Yep.
No,
Someone
I just put
It's in the second
no, Roman, you're wrong.
All right, maybe. All right, okay. Then, it will be in sections. All right, so
Can I have my keys back?
now let's look at the sheet that just says review 2-1 to 2-5. Everybody find it? Review 2-1 to 2-5.
Just get additional. No, get that.
in the back.
That.
All right, we'll get done what we can and we'll finish this this sheet up tomorrow, or at least get as far as you can with it. Number one, write the equation of the linear function with these function values. All right, people, linear. So when you see the word line, you immediately think I need the slope. Remember, these are simply ordered pairs, right?
Yeah.
They're ordered pairs. So slope, -4 minus 3, 1 minus 2. It looks like the slope is 7.
Oh, yep. Oh.
Then what?
You do the point slope.
Pick a point, doesn't matter which one, either one will be fine. I'll pick that one. Y minus 3 equals 7x minus 2. In many circumstances, this would be fine, but it does say linear function, so I probably need to get y by itself. So y minus 3 equals 7x minus 14. So y equals 7x minus 11.
Yep.
And that is your linear function. All right, polynomial function whose zeros are x equals 2 and x equals 3 plus I. All right, what immediately clicks?
3 minus I.
3 minus I. Remember, they never come along. Now, to write the equation, we need to build some factors so that we can multiply everything together and get the answer, right? So, what will the factors be?
X
minus 2,
X minus 3 plus
x minus 3 minus I, x minus 3 plus I. I need everybody to look at that. Make sure you got it. Okay? Now, we'll start the FOIL here because lots of stuff will
Cancel out.
cancel out. So this times all 3. Then this times all 3. Then this times all 3. Alright, so there's a lot there, but what happens to this and this? Gone. What happens to this and this? They're gone. And what about negative I squared? So this is going to be minus 6x plus 10. 9, 10. No, it's not. And we don't want to factor it. It is quadratic, but remember, our job is to write the equation. So now we have to multiply it out, and that will be our answer. So, if I didn't make any mistakes, x cubed minus 8x squared plus 22x minus 20. Hopefully I didn't make any mistakes. Alright, we pick up there tomorrow. Those of you that are going to be here, I would definitely watch the video tomorrow. If you still have homeworks out, get them in.